Hello class. Today we are going to be manipulating formulas. We see the application of this in computer programming and website design. For example, a website which asks you to input the length and width of an area needing to be painted, which can tell you how many paint cans you will need, starts out with an equation and makes sure that you are able to manipulate that equation so that you know how to use the data that is input into the website. Students can find this section challenging because the goal here is not to find an answer like we have been doing. We are so used to finding x equals 1 or something like that as our final step, for example, that it is hard to do in an about face here. That being said, once you get used to the idea that you will essentially be ending up with the same variables that you started with, that we're essentially just shuffling around the formula, you can see that we will be using all of the tools that we have already learned, just applying them in a new way. Let's get started. In the first three equations, we are being asked to solve the following for y. This means that we should get the y variable by itself. The first equation, y minus 3x equals 9, currently has a negative 3x with the y. In order to get the y by itself, let's move the variable. In order to do this, we will add 3x to both sides. Be careful here. When we add 3x to the right, we cannot combine the 9 and the 3x since they are not like terms. Instead, here we will get y equals 3x plus 9. Here we just moved the 3x to the right side so that the y was on its own. The second equation, 2y minus 4x equals 8, will start similarly. We will add 4x to both sides. And this will move our variable. Doing this, we get 2y equals 4x plus 8. Again, we cannot combine the 4x and the 8. This time, the variable is still not alone, so we need to get rid of the 2 in front of the y. To get rid of 2 times y, we divide by 2. Now here we see a difference between dividing here and the equations that we've worked with so far. Instead of just dividing once on each side, since there are 3 terms here total, 1 on the left and 2 on the right, we have to divide all the terms by 2. This means we will have to divide 2y by 2, 4x by 2, and 8 divided by 2. This gives us y equals 2x plus 4. Since y is by itself, we are done with this equation. The third equation, 2x plus 3y minus 6 equals 9, will again start by moving the variable. Since we want y by itself, we will move the 2x by subtracting it from each side. We get 3y minus 6 equals negative 2x plus 9. Then we can move the constant. And this gives us 3y equals negative 2x plus 15. Finally, we will need to divide all the terms by 3. This gives us y equals negative 2/3 x plus 5. In all three of these equations, our goal was to get y by itself. All of the other terms just simply moved to the other side. And this, again, is where students start to have a hard time, is because we're not really solving here. We're not finding an answer. We're just getting this equation into a more user-friendly format, which we will see in the next section. The next unit is going to be asking us to get y by itself so that we can actually graph these equations. The next set of equations that we will look at are formulas. Formulas are mathematical rules that relate to or more variables. We can solve these formulas just like we solve equations. Question 1 asks us to find a formula for length. In other words, we want to solve for the length. We can divide both sides by w. And then we get A over W equals L. This will allow us to solve for the length if given the area and width. I used a similar process last year when I knew how much soil I could afford to add to my garden plot, and one of the dimensions was set because of where the trees and the fence were on my property. Understanding how to find the other dimension of my garden allowed me to put my garden in without going over budget. Question 2 asks us to solve g equals k plus c for k. Here, subtracting c from both sides gives us g minus c equals k. Now, it's really important here to keep the variables as they are. If we started with a lowercase c, keep it. In some equations, big C versus little c can make a big difference. Big C calories versus little c calories are 1,000 units different. Meaning if you mix them up, your answer could be incorrect by a factor of 1,000. Question 3 asks us to solve for n. In the equation, g equals 90 parentheses n minus 4. Following our steps, we need to deal with the grouping first. We have two methods of doing this. I will show you both, and you can decide which one you like better. In the first method, we'll call that method 1. Here in this problem, I will get rid of the parentheses through distribution. We will distribute the 90 to the n and the negative 4. This gives us g equals 90n minus 360. Then we can add 360 to both sides. We get g plus 360 equals 90n. And finally, we can divide by 90. Giving us n equals g plus 360 over 90. All right, so in this problem, so far we have dealt with our parentheses, our groupings. We ended up moving the constants because we didn't have to combine like terms or move any variables. Our variables were already on different sides. And then we ended up dividing to find our final answer. Let's go ahead and take a look at method number 2. This time, instead of distributing, I am going to, for method 2, I'm going to take my original equation. I'm going to rewrite it here. And I am going to divide my 90 on both sides. I know to do that because 90 right now is being multiplied times my parentheses. One way I can get rid of that is through division. So I'm going to divide by 90 on both sides. Now I know that I can, I know that I don't need to divide the 90 by every single term like we did in the middle box at the top, because the parentheses group the n minus 4 together as one item. So I only have to divide by 90 on once on the right and once on the left. The next step here, we get n minus 4 equals g over 90. So then our next step will be to add 4 to both sides. And I get n equals g over 90 plus 4. Now these two solutions don't look a whole lot like each other, but if I take my 90 in this equation and divide each term by it, I get g divided by 90, and then 360 divided by 90 is 4. So I do see that I get the same answer, although this last step is not necessary in order to get n by itself. I do hope, though, at least that this helps to justify why I can solve for n with either method. At this point, you guys can choose which one you like better. Do you like to distribute your 90 first and then solve it? This method 1 would look more like what we have done in class in the past. Method 2, on the other hand, will allow us to get a little bit smaller numbers. We don't have that 90 times 4 to give at the beginning to give us 360, which was a bigger number to deal with. But either way, regardless of which method you use, you will get something that will work the same way. Question 4 asks us to solve a equals 1/2 b times h. In order to get rid of our fraction, since we're going to be solving for h here, we need to get that fraction away from h. I can multiply by its reciprocal, which is 2 over 1. Any number times its reciprocal will give me 1, so those cancel. And then 2 over 1 gives me 2. So I have 2a equals bh. Again, trying to get that h by itself, I'm going to divide by b now. And then I get h equals 2a over b. Again, keeping in mind with these equations, nothing's really going to go away. All I'm doing is reshuffling my equations so that it is in a format that I am looking for. So in this equation 4, the formula that I have right here is going to give me the height if I know my area and my base of my triangle. Question 7 then asks us to solve E equals 1/2 mv squared for m. So we can multiply by 2 on each side. Again, trying to get rid of that fraction, I'm going to multiply by 2 or 2 over 1 on both sides. Any number times its reciprocal is just 1, so those cancel. And I get 2e equals mv squared. Again, I'm trying to get that m by itself, so right now I'm multiplying the m and the v squared, so I'm going to divide by v squared to get rid of the multiplication. And I'm left with 2e over v squared. Go ahead and try the rest of the problems and check your answer against the key. If you have any questions, please let me know.